Digital Subscriber Line, DSL. Think of Digital Subscriber Line, or DSL, as the clever way we taught our old copper telephone wires to speak a new digital language, while cable modems use the coaxial wires from your television. DSL uses the existing telephone lines that were already running into almost every home and business on the planet. It was the first technology that allowed us to move away from the screeching sounds of dial-up and stay connected to the internet 24 hours a day. The magic of frequency, sharing the copper. To understand how DSL works, you have to realize that a standard telephone conversation only uses a very tiny slice of the available frequency on a copper wire. Think of the copper wire as a massive tunnel. Voice calls only use the first few feet of the tunnel, leaving the rest of the space completely empty. DSL uses specialized modems to send digital data through that empty space at much higher frequencies than the human ear can hear. Because these frequencies are separate, you can talk on the phone with your family in Bangladesh while simultaneously downloading a study guide for your CompTIA exam, all over the same physical wire. To keep these signals from bleeding into each other, we use a simple device called a DSL filter or a splitter. You plug this into your wall jack, and it acts like a traffic cop, directing the low-frequency voice calls to your telephone and the high-frequency data to your modem. If you forget to install the filter, you will hear a loud, annoying hissing sound on your phone every time the internet is active. A DSL versus SDSL. In your career, you will encounter two primary flavors of this technology. The version most of us have in our homes is a DSL, which stands for Asymmetric Digital Subscriber Line. The word asymmetric is the key here. It means the speeds are not equal. Because most people download much more data than they upload, think of watching a video versus sending an email. ADSL provides a massive downstream pipe, but a very small upstream pipe. For businesses that need to host their own servers or send large files constantly, there is SDSL, or Symmetric Digital Subscriber Line. As the name suggests, the upload and download speeds are exactly the same. However, you usually cannot use the telephone and the internet at the same time on a standard SDSL line, making it a dedicated data connection. The distance limitation, DSL's kryptonite. If you were to ask a technician about the biggest weakness of DSL, they would tell you one word: distance. Unlike cable or fiber optic signals, DSL signals degrade very quickly as they travel over copper wire. This is known as attenuation. To get DSL service, you must be within a certain distance, usually around 18,000 feet, or about 3.5 miles from the telephone company's central office. If you live further away than that, the signal becomes too weak and noisy to carry any data. This is why you might see a high-speed fiber connection in a city, but a very slow DSL connection in a rural area just a few miles down the road. The architecture, the DSLAM. When your data leaves your house, it travels to the telephone company's local facility. Inside that building sits a massive piece of hardware called a DSLAM, which stands for DSL Access Multiplexer. Think of the DSLAM as a giant funnel. It takes the individual DSL connections from hundreds of different homes and multiplexes them together into a single, ultra-high-speed fiber optic connection that joins the core of the internet. Unlike cable internet, where you share the local loop with your neighbors, DSL provides a dedicated line from your house to the DSLAM. This means you don't usually see the evening slowdown that can happen with cable networks. Troubleshooting and modern tiers. When you are troubleshooting a DSL connection, the most important thing to check is the VDSL standard, which stands for Very High Bitrate Digital Subscriber Line. This is the modern, high-speed version of DSL that can reach speeds of over 100 megabits per second. However, the distance limit for VDSL is even shorter, usually less than 4,000 feet, if a user moves their modem to a different room and the internet stops working. They may have plugged it into a jack that doesn't have a filter, or the internal wiring in the house is too old to handle the high frequencies of VDSL. By mastering the frequency separation of the splitter and the critical distance limitations of the copper wire. You will be prepared to manage one of the most widespread, last-mile technologies in the world.